All right, my name is Mahendra Bairagi. I'm specialist solutions architect, AWS. And it's my pleasure to present driving machine learning and analytics use cases with AWS storage. I have Rob here. Rob Krugman he's a chief digital officer from Broadridge Financial Systems.
Excellent.
And he's going to be a co-presenter. So I'm going to present a few slides first, and then Rob is going to go through use cases later on.
Sounds good.
All right. All right, so let's look at some agenda. So what we're going to talk about today is typical AI lifecycle, then machine learning portfolio from AWS, and then the data needs for machine learning workload. So our idea is to really go through the data today and then come up with the best practices or show you the best practices and what are the different types of data that you use in machine learning. And then Rob will go through the use cases later. Yeah, and then there is a related breakout session later tomorrow, getting the insights from the cold storage, I guess. Yeah, so that is in ARIA tomorrow, Thursday. Yeah, all right. So if you look at the machine learning process, the machine learning is changing what we build, why we build it, when we build it, and then there are tens of thousands of customers, AWS customers using machine learning. And then there are from the various industries, from small companies to large companies, and we've been working with them. And what we found out that there is a typical pattern for machine learning processes. Okay, so the first thing that we do, just like any other computer science application, we need to know what the business problem is, right? So let's say in an autonomous vehicle use case, you are trying to identify road signs. What kind of a problem is this? Is this image classification or object detection, right? There are two different types of problem. They need two different types of solutions. In image classification, you're looking at the entire image and then trying to classify what this is. In object detection, you're looking at different objects on the frame and trying to identify what these things are. The object detection is very, very hard from a compute standpoint. So you need to first define what your business problem is. So if you are, let's say, trying to predict housing prices, then you need to know what type of problem you're trying to solve. So is this going to be a linear regression? Is it just going to be a standard statistical model? So you need to know what the problem is. And then that problem needs to be defined in machine learning terms, right? So is this supervised learning? Is this unsupervised learning? Right? You need to understand the problems. Is it reinforcement learning? If you are working on a robotics project, it can be a reinforcement learning. So understand what that problem is, and then you start collecting the data. So you start collecting the data, then you start integrating the data. So let's say you're looking for automation of the vehicle. Then in that case, you're looking for road signs. So you need to actually understand where that data is going to come from, what type of data it is. Most likely it's going to be images or video. And then how do you get that data? And you collect the data. And then how do you integrate that data with your system? You are not just going to collect the data, but that data needs to be then integrated with your system. And then the preparation of data. So let's say you are looking for housing prices. And then if you live in Santa Clara, and then if there is the housing, what type of a house it is probably doesn't matter, right? All houses are going to be $1 million plus. Probably that data doesn't make sense. So you are going to go and check what data you are actually looking for and prepare that data. If it's an image classification type data, you need to make sure the images are clear, okay? Because the quality of the image determines the quality of your model. Then you prepare that data, and then let's say you are time series data set. Let's say there is a data set where you are trying to predict a solar panel output. Okay, now you have time and then data. So that kind of a data needs a lot of visualization. Okay, you need to see what is going on with the solar panels, that data. Before you actually train the data, you need to plot that data and make sure how the data looks like. So pre-analysis of data before you start building the model. So in a time series, it's pretty critical that you actually visualize, see what the data is. For image classification, object detection, you still need to go to the data and make sure the data is correct. So you still need some platform to visualize the data before you start building the models, right? So first thing, you get the business problem. Second one is convert that business problem to a machine learning problem. Then you get the data. You start feature training. So as I mentioned earlier, the houses in Santa Clara, you probably want to know the zip code, the square feet of the home, but the type of the home or condition of the home probably doesn't matter. So that's the feature. So that probably the feature that's less relevant. So you need to understand which feature makes sense and has a lot of weightage. And then maybe you want to clear those features. Yeah, so that is the feature training. So you get the feature training, and then you start building your model. So in building the model, you need to define the parameters. Okay, you define all these parameters, you start building the model, and then you need to evaluate the model, how the model is doing. But then most of the time, in a machine learning, when you build the model, 80% of the time that what we noticed, as soon as you build the model first time, you're not going to be happy. You got to go back and then change the model. Okay, so you need to improve the model. Model building, machine learning is empirical. Is an empirical problem to solve. So you improve little by little, okay? So it's not like a computer science typical application where you have requirement, you build the application, and your application is ready. Whether it's ready or not ready, it's a digital problem, yes or no. In a machine learning, it's empirical. So you have to go back to data all the time in machine learning. Yeah, so you go back to the data, and then you are going to add new data, that is data augmentation. Let's say you have 10,000 images of signs, and that's not good enough. You got to probably add more. Okay, the second thing is the feature training. Let's say you build the data set. You have a data set, you train the model. You are still not happy with the model. Data is good enough. Maybe the features are wrong. Okay, so you can go back to the features and then retrain the model. Okay, and then once you are done with building the model, then you need to deploy the model. And there are two ways you can deploy the model, or two places you can deploy the model. One is in a cloud. So let's say you're looking for a housing prices prediction, or the stock market prediction, or you're looking for, let's say, insurance claim prediction. So those things you can put on the cloud, and then you can have your customers use that the cloud-based or web-based service. What about smart cameras? What about autonomous vehicles? You don't want to take picture from the car and send it to the cloud and then figure out what this is. Okay, that's too slow. There's too much latency. That's not going to work. So you need to deploy that model at the edge. So you need to figure out how to actually deploy that model at the edge in the car's computer. Okay, so this is a typical process. Again, it's an empirical problem to solve. I have not seen any model that gives you 100% accuracy. Okay, so you got to improve the accuracy little bit at a time. And then it means you need to know the model performance. You need a way to go back to your system, and you go back to your logs, and then you check the performance of your model. So you need a way to get the feedback from the inference back to the cloud, and you can do the analysis on it, right? So for data collection, in AWS, there are services such as S3, Athena, and then Redshift, Spectrum. Then there is a service for ETL if you want to do ETL. So a lot of our customers use those services. Then when it comes to data visualization, a lot of open source tools are available for data visualization. You still need something like Python notebook to do a data visualization. So there are a lot of Python notebook type systems available, or the libraries in Python notebook available. So you need a notebook. You need also a system to manage the clusters. You also need a way to write. You also need to write the connectors to the data. It's not just a notebook, not just a cluster. You also need to have connectors to get the data. And then once that is done, then you also need to secure the artifacts. Like a lot of times the machine learning artifacts, which is basically model, once the model is built, you want to keep it in a secure place. So you need all that process too, right? And then once you are done with securing the model, then you need to actually have a process to go back and deploy the model, monitor the model. And for that, you can actually use the log streaming back to the cloud, something like CloudWatch, getting the data back to the cloud, and look at the model performance. Yeah, and then also sometimes you need A/B testing, because when you load the model in the cloud, let's say you are driving your car in America, and then there is a need to drive your autonomous vehicle in Canada as well. So now you have two different models, because the science in Canada is probably different than America. So you need two different models. So you need a way to use one or other model, right? And you also need a way, when one model is getting updated, is going to be not in use, right? So you need a way where one model is updating, you still have a way to use the previous model. So that's the A/B testing. So you need that too. So in a simple terms, so that was the entire machine learning process that our customers usually use. In a simple terms, what you're looking for is the data sources. They collect the data, right? And then when you collect the data, in the last few years, we've been hearing the term called as a data lake. That's where you have a place you can keep the data, multiple different types of data. So you collect the data, keep it in a data lake, and then use that data lake to build, train, and then deploy the model. Once you deploy the model, you need to start using the model, what we call inference. And once you start looking for the inference, you get what your business goal is to get the analytics out of that model. Okay, while you're doing all this process, you still need to worry about the latency, the throughput, and cost. Okay, so these three things you need to worry about. So to help our customers build machine learning models, we have many machine learning services in the cloud, AWS. Our AWS machine learning services are categorized in 3 different categories. So just like any other computer science application systems, there are 3 systems. One is application level, the platform level, and then the framework level. So at the application level, we already have pre-trained models. Okay, so a lot of machine learning use cases, what we see in the last few years, they are repetitive. Right? So a lot of customers are looking for object detection. A lot of customers are looking for searching the faces. A lot of customers are looking for the emotion detection in faces. So all these things are very standardized use cases. For standardized use cases, we can build models. So if you look at the Alexa, that is also a very standardized use case too. So that comes under natural language processing. So our application services are categorized in 2 different categories. One is visual, and the other one is languages. In a visual, if you're looking for object detection, the searching emotions in a face, if you're looking for a text in an object, if you want to read, if you want to, let's say there's a can of soup and you want to understand what is written on the soup can, so you can actually do that using the service called as a recognition. With the recognition, you can do an image. You can input the image, and you can also input video. So it does analysis on image as well as video. Okay, and then apart from the recognition, for language services, we have Poly. As the name suggests, Poly is for text to speech. Okay, so if you're looking for any very efficient text to speech, there is a Poly. If you're looking for speech to text, we have a transcode. If you're looking for translation services from one language to other languages, we have a translation service too. If you're looking to get the intelligence from the data and then correlation in the data, you can use a service called as a comprehend. With the comprehend, let's say you have a use case where you just launch new product, and then there is a lot of Twitter going on, there is a lot of Facebook going on, a lot of LinkedIn, and there is information in the social media, there is information in your own private data sources too. You can get all that data, send it to comprehend, and you can get intelligence out of that, and you can actually see what the sentiment is for your new product. Is your product doing good or bad? And based on that, the data actually can get that sentiments. So that's the comprehend. And then there is one more service called as a Lex. So if you know Alexa, if you take 2 A's out, that's the Lex. And that's basically what is inside Alexa. So if you are trying to build a model, so if you are trying to build your own chatbots, the Lex is a service that helps you with building the chatbots. Then at the infrastructure level, if you're familiar with EC2, we offer pre-built image, Amazon AMI, for machine learning. So in a data science, you need the machine with all the model frameworks. You need all the libraries. So if you know the AmexNet, TensorFlow, these are the frameworks, very common frameworks. So you need to actually build your machine with these frameworks. You need lot more other libraries along with those. So what we have done, we actually build these libraries already in these instances. So what you can do is you can just go to the EC2 and then get the instance, what we call the Amazon machine learning instance, Amazon's AMI for machine learning, and you can get that instance and you can start using that. If you're already familiar with the building machine learning models, then that instance makes really good sense. If you have a very mature data science program, that instance makes really good sense. You can just go to the instance and then start using that to build your models. But then you saw in my previous slide, for machine learning, you need to build the model, so which is basically get the code. Then you need to train the model, which is running that code, and then try to build the model. And third one is a deploy. So there are three things. So build, then train, and then deploy. So you're looking for three different computer science operations or IT operations. So with the SageMaker, in our platform service, you can do all these three. With the SageMaker, you get a notebook, hosted notebook, the Jupyter notebook, and then you can start building your model. You can start sharing your model with others. Then you can build the model, and then when you build the model in SageMaker, the model is built in a job, and then it's a serverless fashion. So we actually get the server behind the scene, and then we run your model, and then once the job is done, we close. So you only get charged during the duration of the job only. Okay, and then once the model is trained, then you deploy the model. With SageMaker, you can deploy the model as well. Yeah. So and then along with SageMaker, we have one more service called as a Deep Lens. So if you have seen that device, a small device, so if you want to deploy the model in a SageMaker, you can deploy the model in cloud. So it gives you instance, right, in a cloud. But what if you want to test the model on the edge? If there is a use case where, like autonomous vehicles, smart cameras type use cases, if you want to deploy the model on edge, then we have a service where you can actually go to the Deep Lens console and deploy the model on the Deep Lens itself. Yeah. So in my previous few slides, you probably heard me talking about machine learning, and there are two things that machine learning needs primarily: the compute, extensive compute, and then the storage. Okay, so we talk about the compute all the time. Few years ago, data scientists figured out how to use a GPU to build the machine learning platforms, and then with that, a lot of compute problems seems to be solved or getting solved. But for data storage, we still need to actually pay attention to the storage. Yeah. So what are the different types of data that we need? We see in any machine learning. So there is a structured data. There is like a transactional records. Those can be web apps. Those can be mobile apps. Those can be coming from your the backend office systems. Those are the transactional logs. Those are structured logs or structured data. And then typically for a lot of machine learning, the data can be large the media files, videos, the images, or those can be log files. So the log files have been used a lot in past for machine learning. If you look at the spam filters, they need a lot of log files too. If you look at the firewalls, they need log files. So all those things were built using the log file data. And then nowadays we see a lot of IoT devices, right? These IoT devices, they stream the data. Nowadays IoT devices are streaming the videos too. So you need a solution to consider the streaming data as well. Sometimes in machine learning nowadays it's just not the data that is in files in the transactions, but a lot of times now the machine learning needs the data from the streams too. Yeah. So this is the slide that shows you the temperature of the data. Yeah, and the temperature of the data depends on the volume, the frequency of the use, the latency, and then the cost as well. So the hotness of the data, and then it's coldness of the data. So if you have a lot of, if you have a data that needs to be accessed frequently or generated frequently, that's the hot data. Usually the hot data costs money too. Then there is a warm data. The hot data can be something like streams. Warm data can be something like images. And then the cold data is something that can be archived. Okay, so these are the three different types of data that we see. So if you see the hot data, so if you know the Kinesis streaming, so hot data is a streaming. So for streaming, you need something like Kinesis. If not Kinesis, maybe you can use Spark streams. So there are a lot of third-party streams that you can use. So usually a streaming is considered as a hot data. And then there is a lot of data that can be generated in a NoSQL type way, which is not streaming data, but it is still generated frequently. And that data can be stored in a NoSQL type databases, right? Or that data can be stored in something like Redshift too, a little bit. But Redshift is usually used for BI. But if you're looking for any transactional data, the Redshift makes sense, right? And if you're looking for any data that doesn't need a lot of interaction, you can store it in S3, right? And then apart from S3, if your data still needs a lot of transaction, but not frequently accessed, then you can use something like Athena or Presto, the big data solution, or you can use Redshift too. Right. And then if there is a data that is in batches, so far I think the solution that we use for batches is a big data, and you can use something like Hive for that data. All right, so we looked into multiple different types of data, and now we are going to look at the best practices. So if you're familiar with a well-architected program, so in our well-architected program, there are 5 pillars of the well-architected. The one is the operational excellence, then security, the reliability, and then the cost, and the performance and efficiency. So we came up with these the pillars based on our interaction with the customers. We have tens of thousands of customers. We went to all customers, and then understand what it makes their system well architected. And then we generated a questionnaire, and then we go through this questionnaire, look at your architecture, and determine if your architecture is well secured, well operated, reliable, it has a performance efficiency and the cost optimization. So we look into those things, and we give you recommendation, what you should do to make sure your architecture is well architected. So make sure you do well architected process for data lake as well, or your data storage as well for machine learning, okay? And then in the previous few slides, you saw the different types of data, and then the different types of data needs different tools. So you need to make sure that you're using the right tool for the right data. If it's a streaming data, you got to use the streaming solution, okay? So if this data needs frequent use, frequent collection, you got to use something like Kinesis, okay? So with Kinesis, you can get the data as well as video, okay? Then if you're looking for something as a NoSQL type data set, data, key value data, then you can go with something like DynamoDB, right? If there is a data which is just a documentations, again, no structure and just a plain documentation, you can use something like S3. If it's a structured data, you can go with a Redshift, or you can use one of the RDS services. And then if there is a IoT type data, you can use the streams, or the IoT also has a protocol called as MQTT. So you can use protocols such as MQTT and the send data from the devices using the MQTT. And then nowadays there is a popularity for the graph database too. So if your data is graph type data, then you can use graph services, right? And then, so we looked at the right tool for the right data. Now we can look at the tool for the right stack. So in a SageMaker, when you build the model, you need to tell SageMaker where to get the data from. So it's usually S3. Well, it is S3. So you have to point SageMaker job to the S3 bucket. But then, let's say you have a lot of data, and then that data needs to be loaded in the container. And if you don't want to do that, you can actually use pipes. So there is a pipe mode in S3 bucket, in SageMaker, and you can pipe it to the S3 and then stream the data from S3 to SageMaker. Okay, so a lot of people don't know that you can actually pipe it, but you can pipe the data from S3 to SageMaker. Yeah? And then the notebooks come with storage, but if if that storage is not enough for you, if let's say you have a lot of data, you want to visualize that data, that storage is not enough, you can use EFS. So with a SageMaker, you can actually attach EFS and then get that EFS volume to store your data. Okay, so that also one more trick. And then the deep learning AMIs, they are just EC2 instances. With the EC2 instances, you can use EBS. So if you want to load the data on the EBS, that's going to be faster for your model to get the data from the EBS than S3. So if you want to do that, you can actually load your data in EBS and then get that data from the EBS and then start training. Or you can actually use S3 as well. And then for the application services, S3 is the option. Okay, so S3 is a really good option. So what you can do for recognition, you can actually send the bytes to stream, or you can send bytes to recognition, or you can point recognition to S3 bucket. So sending data to S3, sending bytes to the S3 is probably not a good idea. But sending the bytes to the recognition directly is probably not a good idea. It's going to be a lot of latency. What you can do is you can save the data in S3 and then point recognition to the S3 bucket and get the data from there. Yeah, so that's probably the faster way. So for application services, you can go to the S3, point to the S3 and get the data from the S3 itself. So we looked at the different types of data, how to build the models, and then the best practices for the model. Now let's look at the different use cases, and then the storage use cases. Okay. And Rob is going to take over. Oh, there is one more slide, I forgot. So if you are streaming, if the data is on an edge, you got to use the Kinesis, because from the edge to the Kinesis, from edge to the cloud, the Kinesis is a really good option. Otherwise, MQTT is a really good option, but that's not a storage option, it's a streaming option, okay? So the Kinesis is not really for the long-term storage. So once the data is in cloud, then you can actually see what to do with the data. You can process the data, remove the data if you don't need it. If you need it, you can keep it in S3 bucket. Yeah. All right, Rob.
Excellent. Thank you. Hi, everyone. So I'm from Broadridge. Just some background before I go into this. We have a very large business where we work with our clients. We mostly work with financial services companies and help them to store huge amounts of information, often for regulatory and compliant reasons. And as we go through this, you'll see how we actually leverage machine learning and artificial intelligence to actually make this data set valuable and drive a lot of business value. So when we think about storage and archival, and let's be honest, there's nothing more exciting than storage and archival. The reasons companies typically do this is because of regulations, right? You have to store this data for 7 years. You have to store this data for 3 years. There's all different types of regulations. We all are in different industries. We're probably all in a lot of regulated industries. This is why we do this. And if you think about what we do with the content, a lot of it looks like that box in the middle, right? So we all drive around and we see the Iron Mountain truck come and pick up those boxes. You basically put stuff in it, and you never think about it again. Unfortunately, that has been basically the same paradigm that we've used for digital archival. We put the content there, and we never think about it again. And I always joke that what does archival mean? It's where content and data go to be forgotten, right? We put it there, we forget it. So when we work with our clients, I think as people think about how they actually manage their information, historically it's been these monolithic solutions, but more and more companies have a desire to actually use this information for purpose and to drive value. So we've been a partner with AWS for a while, and last January actually, I can actually tell you it was last January 24th because the 25th I had a surgery on my thumb. We all flew out to Seattle and we sat down and we said, If we think about archival and storage, what if we challenged ourselves? What if instead of just making this a regulatory compliance service, if we can actually use this information to drive business value? So that it's not just sitting there. You have to store it anywhere anyway. What if we could actually use it for a valuable purpose? And so as we looked at the solutions that are today that people use, one of the biggest things, obviously from a cloud perspective, is that today's solutions are really cost prohibitive. You have to buy a lot of hardware. You have to buy a lot of software. You tend to buy stuff up front based upon volumes that you may reach or may not reach. That's a problem. The information is captive. You basically put it there, and it's really hard to actually work with the information and to use it. And because of that, the information is typically standardized. There's some type of structure associated with the information, even if you don't want a structure. And as a result, business use is frankly minimal. There's usually information that's made available through a website. Maybe there's some reporting, but not very exciting. So when we started to think about this, we looked at three personas. And you'll see how this drives into kind of an AI and ML conversation in a second. The first one was around operations. Can we actually create a series of services that allows us to engage with the information? In some cases, requiring clients to move that information. In other cases, actually allowing clients to leave the information where it is. The second one was around legal and compliance. And this one has taken on particular interest recently because of two words. The first is GDPR. And the second one is a bunch of words. It's the California privacy rules. Everyone's familiar with those rules? So storage and archival and the way that we manage customer information has evolved significantly, and these rules have basically exploded the way that we've done it in the past. And they require certain things to happen, right? They require a customer to be able to call up and say, forget about my information. How do you find all that information? Right? That's like an interesting use case for machine learning. The last one was, what can we do? Well, even before I get there, the other interesting one is around anomaly detection, right? So can we actually find patterns in the underlying content that we're storing that detects fraud, that detects business problems, may detect opportunities? How can we use this information to drive value? The third one, which is the one that I tend to get excited about because there's a chatbot involved, is the idea of using this information to drive customer service. So if you think about all the data that organizations store, if you think about a typical use case of someone calling up a call center, there's probably someone on the other end that's going into one of these archives to pull up information and provide an answer. Well, there's some pretty interesting things we can do with that information. We're going to walk through a use case in a second. So what we came up with was this concept of intelligent information management. And that name's not overly exciting, but it's this idea of making the data live, making it usable, making us to be able to drive value. So I'm going to walk through a demo, and I'm going to highlight that this demo is actually, this is a captive demo. We recorded this before just because, given the logistics of a room, to actually call into a call center from a room doesn't work very well. And we also recorded it for my colleague, Andrea, who's sitting right over here. So I'm not Andrea, she is, but you'll get the idea as we go through it.
Hi, Andrea. How can I help you today?
Hey, what price did I buy Amazon and what day was that?
Okay, you need to know when you purchased Amazon and at what price. Is that correct?
Yep, that's right.
All right, I see that you purchased Amazon on Wednesday, August 22nd, 2018 at $1,904.90. For your information, Amazon stock is currently trading at $1,945.27, which is up $40.93. Would you like this texted to you?
That'd be great.
Great, the text is on its way. Can I help you with anything else?
Nope, all good. So that use case, what did that use case actually do in the back end? So we actually have a repository. We work, again, with a lot of investment companies. A repository of huge amounts of information around transaction flow, around trade confirms, statements, documents, all types of information. Talking to our clients, one of the typical use cases that they get when people call the call center at somewhere between $5 and $10 a phone call is to call up and say, hey, when did I buy that stock? So in this use case, what the system is actually leveraging is leveraging that information. It's using AI. It's using natural language queries to be able to understand what the user is asking for. And it responds and looks up the information from the underlying data store to solve a business problem. The value proposition here across industries is in the hundreds of millions of dollars because you have the ability to have customer service people focus now on value-added services versus focus on answering routine queries.
Goodbye.
Thank you. So I kind of just went through that, but it interrogated the stored information, it matched the data with the current trade information, it calculated the differences, and it actually sent it as a text to the user. Very robust business problem that we're trying to solve there, and it adds a lot of value. So what did we actually do, and what did we think about when it comes to intelligent information management? Right, so the first piece is the actual secure storage of the information. And interestingly enough, Amazon announced this morning, for those of you who saw it, an addition to S3 called Object Lock, which basically brings worm compliance to S3. It was already in Glacier. And this is something we're pretty excited about because when we had to store the information for compliance purposes in Glacier, we couldn't use it in a real-time environment. Now that it's in S3, and in fact what we were doing is we were storing it in S3 and Glacier. Now that this new feature is available, we can just store the information in S3 and make it usable right there. So that's kind of component number one. The next thing is around this case around how do we actually streamline the compliance and regulatory requests, which for anyone who deals with these, it continually gets more complicated. They add new ones and they don't take away the old ones. And a great example of that is GDPR, where you have regulatory requirements to store information for 7 years, but your customer can call up and say, please delete my information and give it to me. How does that work? The last piece, or some of the other pieces, one was around identifying additional assets, right? And this is, we talked earlier about connectors, right? The idea of being able to connect to not just applications and storage mechanisms that sit within the AWS environment, but also be able to store and integrate into legacy applications so we can pull information out of there. And then the idea of actually adding value on top of that through artificial intelligence and machine learning. So if we kind of look at that, and we look at the structure of how we actually thought about doing this, very much a kind of as-a-service type model, where our approach and our model is that when we create solutions, obviously everything we create is available through many managed solutions, but we also make everything an API so that people can build on top of what it is that we're doing. But the idea of creating this abstraction layer, and within that abstraction layer are all the business value-added services that we can drive across the enterprise and potentially across multiple enterprises. So what does that look like from an AWS perspective? Right, so these are some of the ones we just talked about, but if we go into some of that of using the AI and the natural language through Poly, one of the more interesting use cases is Amazon recognition. And a lot of the information that we end up storing for our clients starts as image content. Right? Sometimes that content could just be a scanned document that came in, an application, for example. And one of the big problems is it's largely very difficult to get that information out. By leveraging a combination of things where we can actually apply recognition to pull the actual content out, and then using machine learning to actually create taxonomies, we can make the information usable, which drives a lot of value. I'm not wearing my reading glasses, so I'm going to have to look at it over here because I can't see what else I have on the screen. So the other applications that we're leveraging is around the use of Cognito to be able to secure the information, and because we are in a multi-tenant, multi-tiered environment where we do work with lots of different clients across our organization. But what gets interesting is on top of the AWS services, we've added this tier of what we call our Broadridge services. This is kind of our special sauce that sits on top of what AWS provides, where we can add these business value functions, insights, web analytics, natural language search, identification of risk and fraud. And what we find very interesting about this, kind of going into the continuous improvement loop that we were talking about earlier, is much like we've done for the last 10 to 15 years when it came to website design and it came to marketing, we're doing the same types of thing now with the actual use of data, where we're continually learning, and those learnings are identifying trends and analytics that we can actually use to create new products, which is pretty exciting. So as I naturally do, I went through that a little bit faster than I probably should have. And I think we have a few minutes here where we're going to actually take some questions from the crowd. So if you have a question, throw it out there. Oh, someone has to have a question.
How did your customers authenticate themselves with that chatbot?
With the chatbot? Yeah, so a number of different ways. I think the idea is that the chatbot can integrate into multiple locations. So one way it can integrate is we can integrate the chatbot into a website where obviously the authentication is there. Through the telephone system, it happens before we actually get called, so they actually go through an authentication process. And then, lastly, through an actual chatbot, where we're actually going through Messenger or something like that, we would leverage the authentication in there. But OAuth is the primary mechanism we're using. Yeah. So, excellent. Any other questions? No. Good stuff. Well, thank you, everyone.
Thank you.